This short tutorial is made to just assist you as you try to understand the estrogen portion of your dried urine test for comprehensive hormones. Presumably, for this particular video, the patient of interest has high levels of estradiol and potentially many of the estrogen metabolites. So here's an example that may be somewhat similar where we've got elevated levels of estradiol. So you can see the premenopausal range is represented here, and the postmenopausal range is way down here. And so this patient, at least for estradiol and some of these metabolites, is far higher than that, which implies generally a lot of estrogen production. So you want to look at the estrogens as a whole and see how much estrogen that you've got, and we're concluding in this case probably that there's quite a bit of estrogen. And then we want to look at metabolism. Now the metabolism in a case like this, which may not represent your particular case, but is especially interesting in that you can see these primary estrogens are elevated, which means you may be making too much estrogen. But in this particular case, you can see that some of these metabolites are low, so there appears to be sluggish estrogen clearance. That can be an issue causing high estrogens, and that's why we want to evaluate the whole picture. So you want to look at the estrogens, you want to look at the estrogen metabolites downstream and see how they look compared to these primary estrogens, but also compared to each other. So to compare them to each other, that's what these pie charts are helpful for. So what you normally get is about 70% 2-hydroxylation, 10% 4-hydroxylation, and about 20% 16-hydroxylation. And it's that 2-hydroxyestrogen that's generally the one you want to see favored in metabolism because it has more protective properties, or is at least thought to have more protective properties. And in this particular case, which may or may not be the case in your scenario, it's at 50 some percent, which is much lower than expected. So again, that represents metabolism that's not going as you'd expect down that pathway, and providers can work with patients on ways to assist with that. So in this particular case, you'd get a twofold benefit potentially of having a better relative metabolism, one metabolite versus the other, but then assisting with that clearance of estrogen can potentially also bring down those high levels of estrogen. So particularly in these cases where you have elevated levels of at least some of the estrogens, you want to evaluate ways to potentially reduce the production of those estrogens, but also to increase the clearance of those estrogens. So in a case like this type of a case where there's more of a pan elevation, everything's high. As we look at the relative metabolism, 70, 10, and 20, I mean, it's pretty close to that distribution. So the estrogens are getting out of here about the way that you'd expect them to in terms of the phase 1 metabolism. And in a case like this, it might be better to focus more of the efforts on the source of those elevations and reducing the production in the first place, inflammation and some other things that can cause elevated estrogens. And it may also help to lower the estrogens to increase and support and assist this phase 1 metabolism. But between these two cases, even though the estrogens and the estradiol at least are elevated in both cases, it is a little bit different, and that's why you want to evaluate the estrogens, E1, E2, the whole class of estrogens, whole family, as well as the metabolism pattern, which also includes methylation, and that's part of phase 2. Now that's also part of being able to properly excrete estrogen. So now in this particular example may be very different than your example because these are relatively low levels, but the point of this is not to look at the absolute levels, but the relative levels. So you can see from these, the 2-hydroxyestrogens are relatively similar in these two cases, and we expect the methylated product to be about half of those numbers. So in the top case, it's much higher than that, which is why the methylation activity is listed as high. There's a lot of conversion going on there from the hydroxy to the methylated product, whereas in the bottom one, there's substantially less of the methylated product, which is then low in terms of the methylation index. If you end up right in the middle of this, then that's exactly average within the population of premenopausal women for the potential for methylation. So If you've got low methylation, potentially you could be looking at nutrient deficiencies or genetic defects in the methylation, and that's something that providers and patients should be working with together, as this impacts not just estrogens but also DNA and catecholamines and other places where methylation may be at play. So I hope that's been helpful, and do see some of our other videos on the other hormones and how they may impact your health.